Hi, everyone. Thank you for joining and welcome to the Dapr community call for April 19th, 2022. My name is Nick Greenfield, and I will be the host for today's call. We have a jam-packed agenda for today. We'll be focusing on the recent Dapr 1.7 release. We'll dive deep into some of the new capabilities that have been introduced. So this is the agenda. We're going to start off with just going over the release highlights, and then we'll dive deeper into some of the big features that have been introduced. So we're going to start off with the release highlights, where I believe Artur will talk us through this release.
Okay, can you hear me?
We can.
Awesome. So first of all, thanks to the community for all the contributions. We had like 83 at least contributors in this release. I think it's the highest we ever had. So I want to go through some of the highlights that the community enabled us to deliver this time. So first of all, resiliency. So this is the first time now where you are allowed to configure retries, timeouts, and circuit breaking in Dapr. And you could do that via a new YAML for the resiliency. And that's configurable for service invocation, actors, and components. We also have enhancements in observabilities. So we have new metrics that we publish now for components. We also have an optional API logging that you can enable in your sidecar, which means that every call into the sidecar are going to be logged just the out. So that's for enhanced debugging. We also have finished the certification test for components in the previous release. And this time we finished to claim them as stable given the community feedback. So we are now claiming 5 new components as stable. And this is following the new process that we have set up in the previous releases. Also, new components for state store. Can you go to the next slide, please, Nick? And we also added new components supporting Query API, Postgres, CockroachDB, and Redis. For Redis, that's optional to use Query if you install using the ReJSON extension. You get that support, and there is instructions of how to set up an index for that. I'm going to show after this summary. We also graduated some features from preview to stable. Actor reentrancy, which allows a method call into the same actor more than once. The gRPC proxying, that has been one of the most asked features implemented by Yaron, and now it's fully stable. It allows you to call into another gRPC service without necessarily implementing the Dapr gRPC protobuf. And automatic state store encryption that, again, encrypts your data in the state store given the encryption key via the secrets API. CLI updates. So now you have support for namespace for the components, configuration, and list commands. And we also create a new command that allows you to easily rotate Dapr certificates. So many people now are reaching the 1-year mark on running Dapr in production. So this command is very handy for you to proactively renew certificates and avoid an outage. We did have instructions before, but these commands will make it easier for you. And don't forget to check out our release notes explaining how to use those commands. And now we also really happy with this new deliverable. We added new ways for you to install Dapr. So first, we enable you for the first time to install Dapr without pulling images from Docker Hub. So you can pull them from Docker Hub as usual. GitHub registry. We are now publishing our images to GitHub registry. And you also can bring your own private registry as well. And the other cool feature now is that we also have an offline installer where you can download a tar file that contains the CLI and all the runtime control plane in a single binary, extract to a folder, and install Dapr from those without also pulling from any external API or external registry. So you can have a complete offline installation that's really good for air gap environments, or if you're in a company that has restricted internet access, you can have that in a thumb drive and install Dapr. We also have Unix domain sockets now available on Kubernetes. So that was usually available in standalone mode before, and now you can use that on Kubernetes as well. I'm going to share my screen real quick for some more highlights. So give me a minute. So these are the metrics that I was referring to. So please check out the URL in the release notes that will show you the details of what exactly are the new metrics you can monitor on. For Redis, there is a documentation explaining how to use read.json and how to set up the index, okay? And to give an examples here. And that is optional. If you don't want to use Redis with query, you don't need to. But if in case you do, here's how to set up the index. Another thing that was not mentioned, but I'd like to highlight is like we now offer actors to be configured per type. So previously we only had the global configuration. Now we can override that per entity, per actor type. That has been one of the another highly asked feature, because not every actor has the same behavior. So that finally allows you to do that. And like I mentioned, we are publishing to GitHub registry. You can download from GitHub registry directly. And I forgot to mention, we also have nightly builds. So if you have a fix that is a master branch that you want to depend on for a local development or even for a pre-production environment, you can fix your image tag to a nightly build and run directly with an immutable tag. That's better than Edge, because Edge is a moving target. Yep, so that's all I have. I'm going to stop sharing and send it back to you, Nick. Thank you very much.
Thanks, Arthur. Can everyone see my screen?
Yes.
Great. So we're going to go deeper into some of these features now that were released in 1.7. We're going to start off with resiliency. This is one that I'm particularly really excited about. So go to the next slide. So I think it's really important to first talk about resiliency, what it means, and the scenarios in which resiliency becomes relevant. So resiliency, also commonly referred to as fault tolerance, right? Unlike monolithic applications, distributed apps are commonly comprised of many microservices, right? There could be dozens or even hundreds of instances for any given application. And so when you have these many microservices, that many moving pieces, the likelihood of a system failure increases. And so it's really crucial that when you're designing your distributed app, that you're designing it in a way that is fault tolerant. And so basically meaning it has the ability to detect and recover from any system failures. And so with that level of importance, Dapr is now providing a capability in this 1.7 release, introduced as a preview feature for defining and applying fault tolerance resiliency policies to your Dapr API calls. So as this is a preview feature, it does require, like all of the preview features, an opt-in. And so hopefully it's not too small, but up here, this little screenshot, this is a configuration spec, just showing an example of how you would actually opt into this feature and be able to leverage it. So in this case, I have features, the name, resiliency, enabled true. At that point, I can now use this resiliency capability. I can define a resiliency spec, which is this screenshot here. And a resiliency spec is the new concept introduced in this capability that allows you to define those resiliency policies for common resiliency patterns, right? This resiliency spec lives in the same location as your components. So you can just provide that components path and have the spec alongside your components, and it will get loaded by the Dapr sidecar, and the sidecar knows how, where, and when to apply these resiliency policies. And just to walk through what this spec is, it's really broken down into two main sections. There's your policies, which you can see on line 7 here. And so the patterns that are first supported are timeouts, retries and backoffs, and circuit breakers. And so within these, on the docs, there's schema breakdown of the different possibilities that you can leverage here within each of these patterns. And then once you have these named policies that you've created here in this section, you can take those named policies and apply them to targets. And so really the targets can be applied consistently across all the Dapr APIs. So you have your apps, which is this example here, with your app IDs as your target service. So really it's service-to-service communication. Anytime I call the processor service in this example, and if some sort of failure occurs, apply these policies. Same goes for components, which really covers state stores, bindings, pub sub, as well as after. So consistently across all the Dapr APIs. And the thing that I really like about this is that the way that this is implemented is very much decoupled from your application code, right? Your application business logic stays business logic. It's very clean, whereas your resiliency in all these patterns and behaviors are defined in this spec. And again, it's up to the sidecar to know when and where to apply these. So I think that pretty much covers it. I will quickly go over to my browser. Like I said, the docs here under operations, there's now a new section called resiliency. There's an overview. This goes into a little bit more detail around the description of this feature. It provides some examples of how more in-depth examples of what the spec looks like, as well as complete examples that are kind of more filled out here for you to take a look at. As well as the different policies I mentioned. You have the different options here for each of these patterns that Dapr supports. So timeouts, here are all the different options that you have to configure, as well as circuit breakers and retries. And then lastly, the targets, where you can apply these policies that you've defined, right? So apps is, again, that service-to-service call. And this is kind of a little diagram to show you where the failure has to occur in order for Dapr to apply these policies. And for each of the components, your outbound is sidecar to your component. Inbound would be things like input bindings and subscriptions, sidecar to your app. And then you have best of both worlds, pub sub, the publishing side, sidecar to the message broker here, and then the subscription side, sidecar to your app. And so this has a lot more information. I encourage you to try this feature out. It is a preview feature. Would love feedback on how this fits your app requirements. Please let us know. GitHub is a great place to provide that feedback. So yeah, that's it. I don't think I'm missing anything. So if I am, anyone feel free to jump in here. But really excited about this, and I look forward to continue making this feature great. So there's no comments here. Again, feel free to use the chat. If there are any questions, we can kind of go take time in between each segment here and address the questions. Otherwise, we'll keep going. So with that, we'll move on to our next capability that was introduced in the 1.7 release, which is API logging. Amelia, the stage is yours.
Yep, thank you. Can we go to the next slide? Yeah, hi everyone. This is Amulya Varote. So I'll be talking about the feature that we added in 1.7, which is API logging. So let's talk about why we added this, right? As an user, if there is any bug when I'm using Dapr with my application and I don't know what, I'm not really sure what API is being called, right? It becomes a little tricky to understand. So we thought of logging those details, logging every API call that my application is interacting with Dapr. So here API logging enables users to see the API calls from their application to the Dapr sidecar, right? This is basically debugging enhancement feature, and API logging is done whenever the particular flag is set. So here the flag is enable API logging to enable to see the API logs, right? And let's say it's just that the default value of enable API logging flag is false, right? Because if we don't have the this particular flag in our Dapr run, we won't be seeing any API logs. But when we have this in our Dapr run command, that's when we start seeing the API logs. So in the same slide, I have an example of HTTP API calls. So this is viewing API logs in self-hosted mode. If you see the Dapr run command, we have set enable API logging flag with as a flag in the Dapr run. So whenever we do that, we start seeing the API logs. So how this can be done on Kubernetes, right? So this can be added as an annotation, which is dapr.io/enable API logging, and that is set to true. This, which is very much similar to how we enable log level in Kubernetes. So let's jump to a small demo that I have. I'll start sharing my screen. So yes, I hope you all can see my screen. So I have a small example from our quick starts, Dapr quick starts itself, and I'm using state management example here, the Python example. So I'll just check what Dapr version I have. And so let's say I'm running my application, and you can see here I added API enable API logging flag. So when I execute this, so my app starts making API calls, and if we see here, that particular API call is getting logged. So here in this log, we can see what kind of API is being called and what type is it, and also it is. I mean whether it's a state store API or service invocation and so on and so forth. So this is for HTTP example. And let's go to gRPC. I'm using Dapr run command again with enable API logging. When I execute this command, so now we can see gRPC API call as well. So this is how the debugging experience has been enhanced. Yep, I think that's all I have. I'll stop sharing my screen. And yeah, if there are any questions, please post your questions in the chat box, or we can have a platform in the end to discuss.
Thank you, Amulya.
Thank you.
Thank you. Okay. Don't see any questions yet, so we can keep moving along. Up next, we have some of the new component metrics that were added. Yaron, would you like to speak to this?
Yeah, sure, thanks. Let me share my screen. And let me know when you can see it.
We can see it.
All right, cool. So as Arthur mentioned, we added many more metrics to Dapr regarding components. So this is really useful if you want to get better visibility into how your components are behaving and also how your app is behaving when Dapr is delivering events to it. So you can see things like event count and latencies for all of the Dapr building blocks. But let's start out with how do you find out that metrics list through the docs. So it's a little bit convoluted at the moment. What you need to do to get to it the easiest is go to the search and then type in metrics list. And then you'll want to click the first option that comes, which is observing Dapr metrics in Kubernetes. Obviously, this needs to be moved. So if there's any docs maintainers on the call, I know there's a few actually, this actually needs to get moved out of the Kubernetes aspect of it. And so under metrics, we have a Dapr metrics list. And if you click that, you'll see the document that Arthur showed earlier. And in this document specifically, these are the newer ones. Now, I'm going to show a small demo for pub submetrics, which is kind of neat. So I have a few pods running in my cluster. This is a Google Cloud GK cluster, nothing special about it. And in here, I have Redis serving as my pub sub, and I have the Dapr pub sub quick start tutorial, the older ones, or AKA the ones I like, better than the newer ones, just because they're easiest to run on Kubernetes. So we have the Node subscriber here and the Python subscriber, and we have a React form. And these are basically just Node and Python applications that listens for events, messages sent through topics. And what I'm going to do now is take this pod and we'll just examine the Node subscriber logs. And we shouldn't really see anything. Yeah, just listening on port 3000. And now we can actually port forward. I don't know if I have that. No, so let's take this. Don't have that saved. So let's do a port forward for, I think this is 80. I'm not sure. All right, I'm actually not sure for the port right now. Let's see, yeah, there it goes. So this React UI is basically just sending pub sub messages to the Node and Python backend. So we're gonna take Node A and let's just input some stuff in here. Hey folks, and a few more messages. All right, 3 messages, and that's good enough. And now we can go back and let's take a look at the logs again. And we can see that we've printed out the logs, the app printed out the logs that Dapr consumed on its behalf. And now if I port forward to this again, and Dapr has a metrics port, which on Kubernetes by default, it's 9090. And if I go here and not make a typo, then we should be getting all of the metrics. And now, unlike earlier versions of Dapr, we can see that we have some really cool metrics here. So for example, let's take a look at these two. This is the histogram. In here, we basically have the sum of latencies, which is 25, so 25 milliseconds, which is the sum for all of the events that we got, and we have the count. And this is pretty good. We have lots of labels that we can take a look at. And if we take the React form, for example, and port forward to that for 9090, and we refresh this. So we can see here that this is pub sub ingress latencies. This is the older application. This is the Node subscriber. So what this shows us is the latency of the application, really the time it took for the app to process the ingress event the Dapr had. Now, if we refresh this, we can see that on the React form, which is the publisher, we have pub sub egress latencies, and we have the topic as a label and the success. And again, we have sum and count. And for basically each Dapr component, you now have these rich metrics for binding, state configuration, secrets. And there's a lot of cool stuff that you can do. One of the cooler things you can do with this, in my opinion, is to pair this up with Kada's Prometheus autoscaler. Kada's Prometheus autoscaler, out of all of its scalars, is by far the coolest one because I wrote it, but also because it lets you autoscale your application based on literally every component that's in existence. So think about, you are able to autoscale your application based on any type of metric that's exposed by Dapr here. But for example, if you want to autoscale your application based on your app's latency or the time it takes it, using Dapr and Kada in that way is a really good way to achieve latency based autoscaling, which is quite difficult in other setups. And then, as far as your imagination can go, you can pick whatever metrics you want to autoscale by, and they'll just work really great. So yeah, I think this is it for the demo. Take it away, Nick.
That's really awesome. Thanks, Ron.
Thank you, Adam.
Any questions? Now's the time. Otherwise, we'll keep moving along. All right. Well, if anything comes up, we have some time at the end. We can always go back. So now we'll take a look at the new offline installer. So feel free to take it away. Shivam, I believe, right?
Yeah, let me share my screen. You can hear me?
We can, yeah.
Can you see it?
Yes, we can.
Okay. So, hi everyone, I'm Shivam, and I'll be talking about the Dapr air gap installer. So, just for the overview, the default mode of Dapr installation is the sort of what we call as the online mode, which is basically a two-step process for a user. So basically, they have to first get the Dapr CLI, like in a self-hosted mode. They have to get the Dapr CLI installed, which they can do either manually or using a script. And once they have the Dapr CLI, then they have to do a Dapr init, which in turn downloads all the required binaries like Dapr runtime, dashboard, as well as the required images. It pulls up and downloads the required images from Docker Hub or GSTR, like the placement container and some other third-party containers like Redis and Zipkin for bootstrapping the dev environment. So essentially, once you have the Dapr CLI, just using a Dapr init gives all you need. It downloads everything for you and have the dev environment ready for you. So we wanted to have the same behavior for the air gap mode. So the air gap installer, as the name suggests, is the offline installer, which is for the users who are in a private network and or they don't have, or basically they have a restricted access to internet, and so they cannot simply pull the binaries from GitHub, or they cannot access Docker Hub or GSTR. So in that case, what they have to do is they have to first get down as a prerequisite, they have to download and save the Dapr bundle. So here the Dapr bundle is essentially an archived bundle that we produce containing all the required things that you need for Dapr installation, like the Dapr CLI first, and then the required binaries, like the ones that Dapr init normally pulls from the GitHub, like the runtime and dashboard, as well as the images, specifically the placement container image. We don't attach the third-party containers like Zipkin and Redis currently in the bundle, do not have the dependency on those third-party images. So essentially, it contains all the required things that you need that are sort of essential for the Dapr installation. And user just have to download it and then save it to their system. So once you have the bundle, you just have to extract the tar file. And then similar to the online Dapr init, you have to do a Dapr init with a from dir flag pointing to the bundle directory. So I will just give you a short. I will just show how like it happens in the online as well as in the like air gap installer. So normally, let me just. I already have the Dapr. Like I'll just show first the online installation. So I already have the Dapr CLI installed. I will just do a Dapr init, and as the logs will suggest, it pulls up the required like images from the Docker Hub. It pulls downloads the required binaries, as I said, like runtime and dashboard, and everything from the GitHub. So now you have, if you do a Docker PS, you can see we have the Dapr IO container running, we have the Redis and Zipkin containers running, and if I do a like the bin folder for Dapr, I have the Dapr runtime as well as the dashboard binaries installed, right? So everything is fine and good. Now let me just uninstall it to remove this installation. So now what you have to do, as I said, as a prerequisite, you have to first get the Dapr bundle. So I already have it downloaded from the Dapr installer bundle repo. So once you have the bundle, you have to extract it. So you will get something like this Dapr bundle folder. You can go to the Dapr bundle folder, and here you see a details.json. So this essentially contains all the like details about like the which runtime version binary it contains, which dashboard version it contains, the CLI version, along with some details about the folder structure, like the Dapr, what is the folder name containing the binaries, what is the folder name containing the images, along with the name of the image and the corresponding file name, right? So it contains all the details. So what you have to do, you have to just use that local Dapr binary, and you have to just use the same init command that you use in the online installation along with the from dir flag. So once I do this, hopefully it will run fine. So here you get a log which says that this from dir flag is currently a preview feature and it is available from the 1.7 onwards itself. So yeah, I have it running, and now if you do Docker PO, you see the Dapr IO Dapr is again up and running. I don't have, as I said, we don't attach Zipkin and Redis currently in the bundle, so they are not there. And then again, I do a Dapr ls. I have the Dapr runtime and dashboard, right? So essentially, you can have the Dapr installation in without having without basically requiring an internet connection, and you don't have to download it. You just have to get the bundle first, and then you have to extract it, and that's all. So that's how you do Dapr installation in the air gap mode. So yep, that's all I had. Thanks everyone.
Thanks, Shubham. Thanks for showing us how to install Dapr in some lockdown or limited network environments. So I'll share my screen again. Okay, next is Raveen, who will talk about will talk to us about support for alternative image registries, GitHub and a private registry. So Raveen, feel free to take it away.
Hello everybody. I'm sharing my screen. My screen visible?
We can see it, yes.
Okay. So about this thing. Like when we do Dapr init, so normally like by default it pulls images from Docker Hub. So with this feature, what we have done is we are uploading images. We're hosting images into the Docker GitHub container registry. And if someone wants to like switch to Docker GitHub container registry for pulling images, so he can do so by using some environment variable, and he can do Dapr init, and basically all the images that he needs it will be pulled from Dapr GitHub container registry. The first feature was this one, and the second feature was if somebody has their own private registry where they are hosting all the Dapr related images, and they want to use that registry because of some network constraint or some kind of firewall which blocks access to GitHub container or the Docker Hub like registry, and they want to use their own managed private registry to pull images from. So they can use with the help of flag, that is image registry flag. So I'll be showing a small demo related to these two things. So as you can see my screen, I'll just check Dapr version. So yeah, and to demonstrate the first thing, which basically pulls images from the Dapr GitHub container registry, we have to set the environment variable, and that environment variable has value of GHCR. Like it's a case insensitive, so we can put it here. And now if we do Dapr init, so basically it is going to pull images from the Dapr GitHub container registry, and yeah, so basically it will pull the images and the binaries, and it will set up everything. So it might take a few seconds more. Yep. So now we can see Docker PS, and we can see this all the images have been pulled from GHCR/IO/Dapr, right? So this is the one feature where if we want to switch to Dapr GitHub container registry, this is the way we can do. So we have to set environment variable, and we have to do Dapr init next. And yeah, so let me demonstrate the second modification to Dapr init. So first I will uninstall Dapr. So now we can see there is nothing, and the way I am demonstrating this thing, I have hosted Dapr Dapr image and the Redis image and Zipkin image in my own GitHub container registry, and I will try to pull those images from there. And I have hosted 1.6.0 version of the Dapr runtime, the Dapr placement container. So I will try to pull the specific version from my own GitHub container registry. So the way we can do so is Dapr init, and we have to give image registry. So this will be GHCR.io I hope I am logged into this. And yeah, we have to give runtime. Hopefully, yeah, we can see that this flag itself is a preview feature, and it's available only after 1.7.0 onwards. So now, if we check Dapr, you can see that these images have been pulled from this particular registry, and the version is this one. So this is about the new enhancement into the Dapr init. Is there any question regarding these two things? If not, I'll move on to demonstrate the second thing, which is about certificate renewal. So this is just to make the certificate renewal process easier, and and the initial process was to have some kind of manual way to renew the Dapr certificates if the certificates are expiring. So now we have provided few CLI commands. With the help of these CLI commands, certificate renewal can be done easily. So to demonstrate this thing, I have done some setup. I'll just try to see if that is fine. So Dapr status -k. Yeah, so I have a cluster, and you can see that I uploaded a expired certificate. So it says that our certificate has already been expired, and expiry date was 31st March or something. So what I will do is I'll try to renew this certificate, and see okay, before that I'll just check all the parts. So I have also deployed a couple of apps, and we can check the container like sidecar logs to see like what is the failure reason for that, and we can check there that the failure reason is because of the certificate has expired. So let me just check the logs for that one. As you can see here, the sidecar container complains about the certificate expiry here. The certificate has expired. So the next thing what I will do is I'll try to renew the certificates using one of these commands. And the command that I'm going to use is probably like put a completely a new certificate, and it will generate the private key and the issuer key and issuer certificate, and it will use the private key to sign these this root certificate and the issuer certificates. So the way we can execute is we can provide a valid until flag, which is optional. So what this means is if someone wants to give a certificate like validity, so he can do so by providing these flags. If we omit this flag, the default value would be 365 days. So let's say we want to create the certificate for 100 days. And at the same time, we want to restart the control pen services because it's a completely new certificate, and we want our Dapr entry to be able to read these new certificates. So yeah, hopefully everything is correct. So you can see that it has recognized the control pen version, and the new expiry is 29th of July, and it is starting the control pen services now. It might take a couple of seconds. Okay, so this has been a certificate has been uploaded. A new certificate has been uploaded. If we check the Sentry logs, um, we might be able to see the new certificate, which is says like 29th of July. And if we check the pods, so if you check the pods, we can see that these apps are still fading because these are having the older workload certificates. So we will have to restart these pods and we'll see that these are now picking up the new certificate. I mean, a workload certificate signed by the new issuer certificates, and these pods will become healthy. So now we can just restart these pods. Sorry. Okay, so this will take some time before all the pods are again healthy, and we'll be using the new certificates. So in meantime, I will try to explain the other commands also. The next command, if you see that I'm expecting a private key. So this is for the scenario where the user is already having the private key of the certificates that he has uploaded, that he has already like uploaded previously into the cluster. So the thing with this command is the user is having the private key, he did not restart the control plane services. The control plane, all the control plane services will be able to read the new certificates created by the same private key. Right. So, and the next command is about if the user is about to provide new custom certificates, so he can upload the new certificates with the help of the third command. He will need to provide all those three parameters that are mentioned in the command. So the root certificate, issuer key, and issuer certificate. So once this becomes healthy, I'll try. Maybe I'll try to check executing one of the commands. Yeah, you can see that our application pods are now fine. And let me execute the one more command to demonstrate uploading a new certificate. I mean a custom certificate. So yeah, so I think I am having certificate created at this location, and I will use this command, which is expecting root certificate, is your private key, and is your public certificate, and we'll upload these certificates to. Before that, I will just show that the new certificates are actually reflected. Okay, so this is because we show these messages only when the certificate expiry is less than 30 days. So since now I put the certificate expiry of 100 days, the warning message will not be appearing here. And same thing we can check in the Sentry logs that the certificate expiry is actually 100 days after it. So just I'll use this command to upload the certificate. I don't remember what expiry I have put for the certificates. Maybe I think 1 year. Yeah, I think it's 1 year. So with the help of this command, what we are doing is we are uploading a custom certificate to our cluster, and the expiry of those certificates are actually 1 year from now. Yeah. Now if you check the Sentry logs, that logs will be appearing there. Is 23. Yeah, that is from my side for the certificate renewal. Any question?
Not seeing any in the chat, but thank you for this demo, both the demos for the private registry, the alternative registries, and as well as the easier cert renewals via the CLI. So thanks for that demo.
Thank you.
So that, I'm going to take over screen sharing, if that's okay. Brings us to the end of the call here in the open discussion. So does anybody have any questions or would like, for anything that we reviewed in tonight's call? To any questions, any additional comments, now's the time. If not, we can wrap this up. I want to say thank you again to everyone in the community that contributed to this release. Again, one of the largest releases that we've had. So really appreciate the engagement on this. And thank you tonight to the presenters for the demos. And yeah, really appreciate it. So with that, I think we can conclude tonight's call and we'll see you in 2 weeks. Thank you.
Thank you.